Hello? 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 Okay. So I think my voice are visible or I am audible to all of you. Is my voice audible to all of you? Please reply. Is my voice audible to all of you? Sophia, is my voice audible to you? Shruti, am I audible? Am I audible? Okay. So we shall start today's lecture, and the point for today's lecture is cryopreservation. Uh, Welcome all of you. Welcome to the Biological Life Sciences channel. So in today's video, we are going to see what is cryopreservation. Okay. So I welcome you all for this lecture. So let's discuss today about the cryopreservation. Okay. So we are going to begin with the lecture in step by step manner. Okay. So let's start. Okay. So the word cryopreservation, it is derived from a Greek word. Okay, Greek word is used for deriving this word, that is cryopreservation. Here, cryos means frost or cold. Okay, so it is cryos. Okay, and preservation means preserving in a cold condition or preserving in a frosted condition. That is called as cryopreservation. Okay, so it literally means frozen state. Okay, so the principle behind this is to bring plants and animals to a stage of zero metabolism. We have to arrest the growth of plant or animal or stop its metabolism so that it will be in a non-dividing state by reducing the temperature. Okay, so while reducing the temperature, you cannot reduce the temperature as it is. You have to first add some cryoprotectant in that. What are the cryoprotectants? So cryoprotectants are generally the chemicals that helps in protection of these kind of animal tissue or plant tissue. Okay, so this helps in protection of this plant tissue. Okay, so these are called cryoprotectants, and this has to be first added into the medium or into the preserving vessels, and then you have to protect that. Okay, so it can be done at three different temperatures. There are three different temperatures for cryopreservation. First is low temperature, that is deep freezing. It is generally done at -80. Okay. Then in vapor phase nitrogen, the preservation can also be done, and the vapor phase nitrogen temperature is -150 degrees Celsius. Okay. And then of course in liquid nitrogen also you can do the preservation, and the preservation in liquid nitrogen is done at -195.8 degrees Celsius. Approximately it is -196 degrees Celsius. That is the melting temperature of liquid nitrogen. Okay, so this can be done in three different stages. Okay, so why preservation is important? See, whatever the material, whether it is an animal tissue or a plant tissue, if you are preserving it, it will not remain as it is for a longer time. Okay, so preservation helps in maintaining the original state of that particular tissue for a longer time. Okay, so the preservation techniques are implemented or used by mankind for a longer time. If I want to quote a ancient preservation technique in which different bodies of man and animals are preserved in formalin in Egypt, in the form of mummies and all. So this is one of the ancient preservation technique in which the original state of that particular body is preserved by using certain chemicals. Okay, so in cryopreservation, you can use or you can preserve the economically important species of plant as well as animals into the different forms. Okay, so endangered species are also preserved like that. Okay, so the why the cryopreservation is used? See, remember the other preservation methods that are present nowadays or earlier also, these cannot preserve the tissues or these cannot preserve the species for a longer time. Okay, so cryopreservation is a potential in which the plant tissue or live tissue can be stored for a longer time, and the most important thing is this tissue is viable. Means what? This tissue is lived, or this tissue is live, still live after, even after the cryopreservation. Okay, so therefore this is one of the important technique that is used as a preservation. Okay, so there are various methods of storage under cryopreservation. First is cryopreservation itself, in which the nitrogen or liquid nitrogen is used as a storage substance here, and the cold storage also can be done. This can be done at the freezing temperature as well as non-freezing temperature. Okay, so in sometimes we store the chemicals at low pressure also, in which the pressure or the atmospheric pressure of surrounding is reduced in order to reduce the degradation of that particular molecule, or low oxygen storage also can be done. The basic example is the commercial chips and all which you get commercially. There also the oxygen content present in such packaging is low. Why? Because oxygen brings about the oxidation of different organic molecules. Okay, so when you reduce the oxygen content in such packets, the oxidation of such kind of molecules or oils or fats present in such kind of material, food material, is reduced. So sometimes we also go for low oxygen storage. Okay, but we are here concerned with the cryopreservation only. What are the different advantages here? So once the material is successfully conserved to a particular temperature, it can be preserved indefinitely. Okay, you can go for around 10 to 15 years of storage also. Okay, once the storage, there is once storage, there is no chance of contamination, because the fungal or bacterial contamination cannot occur at such low temperatures. Okay, so therefore it is very advantageous. Okay, and minimal space is required, only cryo container is required and cryo protectant is required, and minimum labor is also required, because a single person can easily also do this kind of preservation. Okay, so let's see the mechanism of cryopreservation, which is very important here. There are different steps in the mechanism of preservation of plant as well as animal tissue. First of all, the first step is selection of material. Okay, the material which you are selecting for the cryopreservation is very important. Why? Because the material that you are preserving, is it worth preserving or can it be preserved? Okay, that these are all the different criteria that are involved here. Okay, so here the material that should be selected for preservation is very important. And then next step is addition of cryoprotectant. Okay, cryoprotectant are different chemicals that I am going to tell you in this presentation. These chemicals has to be added into the this medium or this substance which needs to be preserved. Okay, and it helps in protection of that particular species while drying. Okay, that species can degrade also, or that plant molecule or the plant animal molecules in that particular tissue can degrade also. So therefore the addition of cryoprotectant is very important. Okay, and then the next step is freezing or reducing the temperature. Okay, then after that, storage in liquid nitrogen. You cannot directly plunge the tissue in liquid nitrogen. First of all, you have to freeze it, and then gradually you have to shift the storage to the liquid nitrogen. Okay, as it will ensure the slow drying or slow freezing of that particular material, and it will not harm that particular material. Okay, then comes the next step, that is thawing, and after that washing and reculturing, and then when you retrieve that particular stored substance, again you have to measure the viability, whether that particular substance is in living form or not. Okay, otherwise there is no use if the person if the molecule or the plant tissue or the animal tissue gets dead, there is no use. Okay, so measuring the viability is also very important. Okay, and the last step is regeneration of plant and animal from that. I'll quote few examples here, a few examples of different tissues or cells that can be cryopreserved under this category. Okay, the first step is selection of plant and animal. Let me elaborate on this. There are two important factors in which you are selecting. First is the nature and second is the density. Okay, the nature of the tissue should be live, obviously, and it should be freezable. Okay, then density also. Whatever the tissue you are taking for the cryopreservation, it should not be dilute. It should be concentrated one. Okay, you can select any tissue for cryopreserving. There are certain examples, for example, meristem, embryo, ovules of different species of plants, seeds, tissues, organs, semens also, ovules also, oocytes also you can preserve. Okay, the density should be high here. Okay. Second step is the addition of cryoprotectant. There are different chemicals that are available that ensures the protection of these tissues while cryopreserving this tissue. First is sucrose, then alcohols. Certain glycols are there. Example, ethylene glycol. Certain amino acids, for example, proline and DMSO, dimethyl sulfoxide. These kind of chemicals acts as a cryoprotectant that protects your tissue while preserving it in a very low temperature. Okay, so generally two cryoprotectants are used at a single time because they are more effective. Simply they are more effective. Okay, let's see the next step, that is freezing. So now in this step, the after adding the cryoprotectant, the temperature is gradually lowered. Okay, the sensitivity of cells to the low temperature depends on the species. It is different for different species. Okay, so there are four different methods of drying. Okay, you cannot directly plunge it into liquid nitrogen. First is slow freezing method. Okay, first method is slow freezing method. The tissue or cell is slowly frozen at a slow cooling rate. Gradually, slowly the temperature is reduced. The advantage is cells are partially dehydrated here and they survive better. The survival chances of cells are better in this slow freezing method. Okay, let's see the next one, that is rapid freezing method. It involves plunging the vials in liquid nitrogen. Directly you have to put the vials in liquid nitrogen where the temperature can be reduced from minus 300 to 1000 degrees Celsius rapidly. Okay, this can be easily done. Okay, by plugging it into liquid nitrogen. Certain tissues require such kind of drying also. So you have to select what kind of drying method or freezing method you have to use. Okay. Then stepwise freezing method. This is a combination of both slow and rapid process, and this is carried out in a stepwise manner. Okay. Then dry freezing method, in which the dehydrated cells and seeds are first stored and then they are dried. Okay, after freezing, how they can be stored, the storage is very important. Let's see the storage. The maintenance of frozen cell or material at a specific temperature is very important. The temperature maintenance is very important here. Okay, so you have to maintain the temperature throughout while storing, and in general the temperature is kept at minus 72 minus 195.8. This is the exact temperature, that is melting point of liquid nitrogen. Roughly we take it as minus 196 degrees Celsius. Okay, and then to prevent damage, you should provide the liquid nitrogen continuously. Otherwise, what will happen? The liquid nitrogen will eventually boil off, and it will be the can will be empty. The cryoprotectant can will be empty. Okay, so therefore you have to continuously add liquid nitrogen. You have to maintain the supply of liquid nitrogen here. Okay. The next process is thawing. See, from now I will tell you how to retrieve the protected. Till now, the fourth step, we have stored the chemical, cryoprotected the chemical. Now, if you want to use it, then how to use it? The first step is thawing. Okay. Now, what is meant by thawing? It is usually carried out by plunging the liquid vials or the frozen vials into warm water. Okay, and you have to vigorously swirl it. You don't have to shake it, you have to swirl it. Okay, due to this, what is going to happen? Gradually the tissue will try to come at the normal temperature. Okay, so thawing is very important. After that, washing and reculturing. You have to wash it, wash the material, because we have added the cryoprotectant into that, so you have to wash it first with a double distilled water. After washing, the cryoprotectants are removed, then the medium is cultured on the fresh medium. Okay, And after that you have to measure the viability, whether your tissue is live or dead, that also you have to measure. And this is possible, see, during storage, obviously there is a stressful condition for the cell. Okay, the cell may die in this condition. Okay, so for this purpose you have to check the viability. Okay, so it can be calculated by the formula number of growing cells divided by number of cell thawed into 100. For example, if in a single instance you are thawing 1000 cells, okay, and out of that 500 cells are living, so 500 divided by 1000 into 100, like that you have to do. Okay, so you can calculate the viability of that particular cell. Okay, then the next step is plant regeneration. It can be animal regeneration in case of animal cells. Here you have to culture again on the suitable environmental condition, and you can get the live culture. Okay, so there are different applications of this cryopreservation. Let's see one by one. You can get disease-free plant that can be conserved and propagated, and recalcitrant seeds can be maintained for a longer time. The seeds which are not viable or which lose their viability very soon, such kind of seeds can be maintained under this. And then endangered species which are not easily growable, such kind of species are also, the germ plasm of such kind of species can be preserved. Okay, you can preserve the pollen grains of certain seeds also. You know, for example, plants like bamboo, which flowers in a very large interval of time. Yes, so flowering season is very large. So you can preserve the pollen grains of such plants, and then you can use it for further cultivation also. Rare germ plasms and other genetic manipulations of different organisms can also be stored. Okay, then suitable tissues such as semens, embryos, oocytes, ovarian tissue, testicular tissue of very important organisms which are endangered or which are extinct can also be stored under cryopreservation. Okay. So let's see how embryo can be preserved. It is used for embryo storage where in vitro fertilization results in more than one embryo. Okay. So now see how important this is. You can imagine the pregnancies have been reported from the embryos which are stored for more than 16 years. So embryo which was fertilized, and after fertilization till the embryonal stage or blastula stage, such embryo are stored, and pregnancies have been reported after 16 years. So you can imagine the potential of this particular technique. Okay, the result has been uniformly positive with no increase or birth defect. Moreover, not only viability is checked here, but the particular embryo has grown properly without any abnormalities. That is also very important. Okay, then ovarian preservation. Ovarian tissue can be preserved where certain characters are important. Tissues of ovary can be preserved here. Okay, here sometimes what happens, the reproductive potential of women's who are having cancer and all is threatened. Okay, so women can go for cryopreservation of their ovarian tissue. Okay, so that in future if she wants a baby, or if the couple wants a baby after getting from cancer or getting cured from cancer, then she can even go for surrogacy, in which her ovarian tissue can give rise to the fertilized proper viable ovum, and such ovum can be in vitro fertilized, and then by surrogacy such couples can have children. Okay, so ovarian preservation is very important here. This can be done in breast cancer also, in which the tissues can be preserved. The procedure is to take ovary and perform slow freezing and storing in liquid nitrogen. You can surgically remove the ovary and then preserve it. Okay. Then oocytes also can be preserved. Preserving ovary is more tedious task. Preserving oocytes is more better or more easier, like Siemens. Okay, so human oocyte cryopreservation is a new technology in which women's eggs are extracted, frozen, and stored. Okay, you can store this. Okay, later when the woman is ready to become pregnant or ready to conceive, these eggs can be thawed and fertilized, and then implemented into the uterus of such women. Okay, so this is oocyte preservation. Cement cryopreservation is another very important aspect of cryopreservation. This is not only limited to human beings but used for number of animals, such as in case of buffaloes, cows. The male partner or the male buffalo or ox, their semens are stored under cryopreservation, and this can be used for different kinds of breeding techniques. Okay, So the longest storage is for about successful storage is for about 22 years. So you can, see the potential of that. Okay. And nowadays also there are different banks, sperm donation banks, where recipient wants to, store their semens, and the other stem cell banks are also there, in which the embryonic cells or the umbilical cord is stored under cryopreservation. And umbilical cord banking is one of the potential important technology that is coming up, and people are expecting this, accepting this technology over the time. Okay, though it is expensive now, but gradually in the time to come it will get cheaper. Okay, then testicular cryopreservation, in males also, the gonad can be prepared, or the preserved, or the testes can be preserved in males. Okay, so sometimes what happens, the if the male is having certain disease or is about to get certain disease, he can preserve his testes. It can be done for different kinds of species. Okay, different animals also it can be done. Okay, so it is one of the important technique. Okay, then significance of cryopreservation, obviously cryopreservation of gametes, embryos prevents the genetic drift. Okay, then it safeguards the genetic integrity, or the valuable strains are also can be preserved. Okay, it offers generation time and others for further contribution of genetics. Then it also provides the ease of transportation of genetic stocks, because the cryoprotectant can be easily transferred into the different kinds of vehicles and all, and it can be easily moved from one place to another. Okay, it causes the decrease of disease transmission also, because there is chances of infection are reduced greatly in cryopreservation. Okay, okay, so still now we have seen the cryopreservation and all. See, cryopreservation is not possible without handling the liquid nitrogen. Okay, so liquid nitrogen handling is also very important. Okay, so let's see how to handle the liquid nitrogen safely and use it judiciously and properly. Okay, the awareness of training is intended for the laboratory use of liquid nitrogen. Okay, so liquid nitrogen, what happens, as you know, the temperature of liquid nitrogen is about minus 196 degrees Celsius. Okay, so the liquid nitrogen boils off at minus 196 degrees Celsius. Okay, so it is in need a very low temperature, and it can be dangerous. Okay, it can cause frost bite and all in human beings. Okay, so you have to handle the liquid nitrogen very carefully, and here we are going to discuss that. Okay, so let's see manufacture of liquid gases. So normal air, which is normal air, is compressed and cooled, and as the temperature drops, different gas liquefies. Okay, so exactly at minus 196 degrees Celsius, the liquid nitrogen, or the nitrogen present in air, liquefies. Okay, and then this is collected separately. So here remember, the liquid boils violently to get back into its original gaseous state. So you have to need very careful while handling this. Okay, so let's see what is the characteristics of nitrogen. First of all, obviously you know that it is about 78% of the atmospheric composition. It is a colorless, odorless, tasteless, and not non-toxic gas. Okay, one more character of liquid nitrogen is it controls all the burning processes on earth. Okay, whatever, it does not support combustion, that is, it does not support burning. Okay, it boils at minus 196 degree. It is non-flammable, and it will not support life, and it is lighter than air. Okay, see, wherever there is liquid nitrogen storage is done, in that area there is a oxygen deficient atmosphere. Liquid nitrogen tends to diffuse in the atmosphere in that particular area, and the oxygen concentration in that particular area is very low. So wherever you are storing the oxygen or liquid nitrogen containers, there should be oxygen monitoring system, and there should be ventilation also, because it may be prudent to install oxygen monitors in area where liquid nitrogen is stored and ventilation is minimal. Okay, so it can create a temporary oxygen deficient atmosphere, which is very harmful. So you will not be able to find out that oxygen deficiency is occurring in that particular area where liquid nitrogen is stored, but you should know that it causes the liquid oxygen deficient conditions. Okay, so characteristics of oxygen deficiency, how are you going to know whether there is a means if you are working in a liquid nitrogen atmosphere, and how will you know that there is an oxygen deficient condition formed or not? So it will form aphyxia, develop slowly as the oxygen content of the air reduces from 21%. Generally, it is 21%, and if it is reducing, then aphyxia will be there. There will be slight nausea also, and the person will not be able to breathe properly. So such kind of conditions are there when the oxygen deficiency arises. Okay. So characteristics is oxygen deficiency of how it occurs and what should you do. All cryogenic containers should be stored in a well ventilated area where ventilation is proper. You should store this in that area. Okay, so a high concentration of nitrogen reduces the breathable oxygen in the air, so you have to be very very careful. And the filling between the containers, the leakaging valves, liquid tank venting should also be avoided. Okay, see, nowadays the generation which is present now, they find it funny, yes, but it is not at all funny. The different people use the liquid nitrogen for dipping different kinds of biscuits and all. That's a trend nowadays, but it is not good. If you are accidentally exposed to liquid nitrogen, it can cause severe frostbite. You should remember this. Okay. uh, See, I have already told you the different, primary hazards that liquid nitrogen can cause. Generally, liquid nitrogen are stored in a very specific cryogenic container. Okay, you cannot store it in liquid nitrogen in any container. It has to be stored in a certified liquid nitrogen cryopreservant container. Okay, so proper, and proper delivering or proper filling of this container also should be done by a trained person. Okay. Let's see some facts of liquid nitrogen. I already told you minus 196 degrees Celsius, that is 320 degree Fahrenheit is the boiling temperature. The volume expansion rate is 696 for liquid nitrogen. You can see the photo of liquid nitrogen boiling here at minus 196. So these were the different facts. For you to know about different gases, I will be sharing some data of certain gases. Let's see, first of all, nitrogen. Its boiling point in Fahrenheit and degrees Celsius is given here. You can see liquid nitrogen boils off at minus 196 degrees Celsius. Volume expansion is 696. Whether then oxygen is minus 183 degrees Celsius. Okay, so liquid nitrogen is more cooler than liquid oxygen. Then comes argon, that is minus 186, and then minus 253 is for hydrogen, and more or less than that is for helium gas, that is minus 268 degrees Celsius. You can imagine the minus 268 degrees Celsius is so low temperature, and the absolute zero temperature is minus 273 Kelvin. Okay, so this is a very low temperature, and this temperature sometimes cannot be achieved on Earth also. Okay. So let's see some facts. 1 cubic foot of liquid nitrogen will expand to 696 cubic feet of 100% gaseous nitrogen at 70 degree Fahrenheit. You can imagine 1 cubic feet of liquid nitrogen, if you store in a particular area and allow it to expand, it will expand to the 696 cubic feet of that particular area. So the expansion is very large. Okay, and it can displace the oxygen in the atmosphere. It will remove the oxygen in the atmosphere for that particular area and creating a temporarily oxygen deficient condition. So in need, you have to handle the liquid nitrogen very carefully. Okay, so there are certain steps. You have to read all the container label, all the precautions labeled to the container properly while using the liquid nitrogen. And it always must be, whatever the cryogenic container that are present, that has to be kept in an upright position in order to avoid the spill of nitrogen. Okay, cryogenic liquid should be handled in an open pailed type container or unapproved devars. Okay, you have to put that or store that container in an open container. Okay, and the transfer of liquid into warm lines container must be done slowly to prevent a thermal shock. Okay, so it is it has to be carefully used. Okay, you can see the person pouring the liquid nitrogen, and it has to be very carefully used. Okay, you cannot touch the liquid nitrogen with bare hands. Okay, always wear safety equipments including cryogenic gloves. There are specific gloves for that, and then face and eye protection is also advised. Okay, high concentration of escaping gases should not be allowed to collect in an enclosed area. You should always do it in an open area. Avoid prolonged breathing of cryogenic liquid vapors. You whatever the vapors that are there, that also you should not breathe for a longer time. Okay, and these kind of shields should be used. Okay, you have to check the liquid container in which the the cryopreservant is stored or liquid nitrogen is stored. Use adapters. Never attempt to change or remove any fitting. Okay, don't try to be over smart. There are thermos approved bottles and different companies are also there that manufactures the liquid nitrogen containers or the cryopreservant containers. So such containers you should use. Okay, so different types of liquid nitrogen cylinder. These are the different containers shown here. uh, you can store carbon dioxide also, nitrogen dioxide also, you can store oxygen also and nitrogen also. So such containers are built to store all these kinds of materials. Okay, these are also called as liquid cylinders. Okay, so low pressure liquid cylinders are also there for dispensing liquid only. Then liquid and gas high pressure cylinders are also there. So different kinds of cylinders are available, and different kinds of security is also provided in such kind of cylinders. Okay, so how these are constructed, you can see there is a different insulated space that is present between the actual container inside and the container outside. Okay, so it is done for the insulation purpose. Okay, the insulation is very important, or else if you touch the inner cylinder, your hand will get stuck to that, it will freeze to that particular tank. Okay, so therefore such kind of insulations is also provided, and double security is used. Okay, even in between there is a vacuum to prevent the heat leak and all. There is a presence of vacuum, and so that this liquid nitrogen can be stored for a longer time, and ambient temperature is also maintained and in between these two containers. Okay, so there are pressure relieving devices also that are added, that can be used as a control valve, because the liquid nitrogen converts to gas at a very rapid pace. Okay, so here therefore pressure relieving devices are also there, that releases the pressure if it is increases more than 350 psi. Okay, so such kind of gauges should be present to your container. Okay, as you know, the liquid to gas conversion rate is very high. So about 2.3 gas per day under an ideal condition will always be lost. Okay, so you cannot store a particular amount of liquid nitrogen for a longer time. So you have to use it also fast. Okay, and there are different sensors also that are present, which calculates the amount of pressure of the gas or the amount of gas available, and these are always fitted by weight. Okay, this is the different valves or rupture valve, liquid level gauge, vent valve that is shown in different containers. Certain pressure of different liquids is shown here in this slide. For liquid, operating pressure is 22 psi, and for gases the operating pressure is 350 psi. Then head pressure of different containers is given. Low pressure containers valves is given. Again the diagram is shown. So such kind of signs are always placed into the where all the containers where different kinds of instruments, such instruments are used. It should be certified also. It is certified by different companies, and this kind of symbols or warning signals are also given. Okay, so this was all about the liquid nitrogen storage and handling and cryopreservation. If any doubt, please put your doubts in the comment section below. Okay, and be safe. Thank you for your participation in this lecture. Thank you for attending the lecture.